You may already know that a catalyst is a substance that speeds up a chemical reaction, but here's an everyday use of a catalyst. Araldite is a strong adhesive, and the adhesive works by a polymerization reaction. The hardener, which is the catalyst, is mixed in with the monomer in the resin, and this causes the reaction to occur very quickly, and that hardens the araldite mixture. So at foundation level, you need to understand that a catalyst speeds up the rate of a chemical reaction, and you need to be able to describe the catalyst as a substance that changes the rate but is unchanged at the end of the reaction, and therefore only a small amount of catalyst is needed to catalyze large amounts of reactants, because the catalyst can be used over and over again. One commonly used reaction which involves catalyst is the breakdown of hydrogen peroxide. Hydrogen peroxide will decompose to water and oxygen gas very slowly under normal conditions, but if a catalyst is added, normally a metal oxide catalyst, then the reaction is very much faster. In an experiment in school, we might compare the action of various metal oxides to find out which works as the best catalyst. And in this case, you would repeat the experiment using the same volume and concentration of hydrogen peroxide and the same mass of catalyst, but changing the metal type of catalyst. So for example, using manganese oxide, copper oxide and lead oxide, and seeing how much gas is produced every 20 seconds until the reaction is over. If we were to do this, we'd see that the uncatalyzed reaction would be practically non-existent. It would produce very, very few bubbles. However, different catalysts might produce a faster reaction, and of course the reaction which produces the most gas in a given time will be the one which is using the most effective catalyst. And manganese oxide, the black line here, would produce the largest volume of oxygen gas in the shortest time because it's the most effective catalyst. So a catalyst speeds up the reaction, but it isn't used up in the reaction, and there is just as much catalyst left at the end as when you started. So in summary, a catalyst is a substance that speeds up a chemical reaction but remains unchanged at the end of the reaction. So if we'd started off with 1 gram of manganese oxide in this reaction, we would have filtered off the catalyst at the end and ended up with exactly 1 gram of the catalyst, which would be just as effective to use the following day. Now only a tiny amount of catalyst is needed because this catalyst can work on many reactants one after another. And catalysts are specific to particular reactions. So for example, in C2 we learnt about the Haber process, which is the reaction which makes ammonia, a reaction between nitrogen and hydrogen, which is speeded up by using a catalyst of iron. Whereas in this reaction we've just looked at here, the decomposition of hydrogen peroxide, the catalyst was manganese oxide. That was the most effective catalyst. In biology, you will have learnt about enzymes. Now, enzymes are biological catalysts. These are proteins with particular shapes which bind to specific reactants and make them react very much faster. We have enzymes, for example, in our gut in order to break down food, and specific enzymes are used to break down specific food types. Here's an exam question. Louise and Mike investigate the decomposition of hydrogen peroxide solution, and look at the diagram. It shows the apparatus they use. So they're using a solid as a catalyst. They've got some hydrogen peroxide solution and they're collecting the gas here in the gas syringe. It says look at the word equation for the reaction hydrogen peroxide making water and oxygen. On its own, hydrogen peroxide solution reacts very slowly. A solid must be added to make the reaction faster. Louise and Mike add different solids to hydrogen peroxide solution. They work out the rate of the reaction each time and look at their results. Then it says look at their results. Now what they've done is done the reaction without any catalyst added, and you see that the rate of reaction is very slow, a relative rate of 1. And then they've used 4 substances, A, B, C and D, and looked at the rate of each. Now it appears that D doesn't seem to do anything to the rate of reaction, but A, B and C seems to have speeded up the reaction considerably. The first question says what solid does not change the rate of reaction. Well, that would be D. And then which solid is acting as a catalyst for the reaction? Well, first sight suggests that our answer could be either A or B or C, but then we look at the mass of the solid before and after, and it's changed with A and it's changed with B, but only C has the same amount left at the end. And as we know that a catalyst is a substance that speeds up a reaction but isn't used up or remains unchanged at the end, the answer to that one must be C. And we'll say Y, and make both those points, that C speeds up the reaction but is not used up. It remains unchanged at the end. And just confirming from the mark scheme, the substance that isn't a catalyst at all is D because it has no effect, and the one which works as a catalyst is C, and the answer is because it increases the rate of reaction but it remains unchanged at the end.